Hello, in this video, let's look at Chapter 4, Mathematical Expectation. The 4.1, Section 4.1, it says introduce the mean of random variable. Well, in the Chapter 1, we have already discussed the mean of a variable, okay, the mean value. So basically add all the numbers together, divide how many number you have, or divide by the total frequency, okay? So in this section, then we don't have like data, but we have a random variable. Okay, so to calculate the mean of a random variable, what we do is the mean value we define as e of x, okay, equals the variable multiplied by its distribution. Okay, for continuous function, the expectation value equals takes negative infinity, the variable x, random variable x multiplied by the its corresponding probability distribution function. Okay, the probability function. Then take the antiderivative. Okay, this is for discrete variable. This is for continuous variable. Let's look at example. Example 4.1. A lot contains 7 components sampled by a quality inspector. The lot contains 4 good components and 3 defective components. A sample of 3 is taken by inspector. Find the expected value of the number of good components in this sample. So it says find the EX. So before we find the EX, we need to find out all the probability. Okay, so probability function of F0 means there are 0 good components, 0 good components. So we choose 0 from 4 and choose 3. You have all 3 from the 3 defect. No, choose 0 from 7 components, 3 defective, 4 good. Okay, 0 good, which means all 3 are defective. Okay, the total is choose 3 from 7. Well, it does actually, in the example, you can see this is for 0. You have to do 1, 2, 3, and continue to do F1. Choose 1 from 4, choose 2 from 3, and choose the 3 from 7, the total. Okay, so you have a function which is choose Fx. Okay, this is the probability function. We find F0, F1, F2, we find all of them. The Fx is given here in the example. You can do it by yourself. You choose x from 4, basically we have 4 good, number of good components, and then total number is 3 components. So 3 minus x will be the bad ones, and we have 3 in total as bad, and then 7, and we choose 3. Okay, so this is the total. This is the all the combinations, and then we find x equals 0, 1, 2, 3. Okay, we find all the probabilities. So the probability will find F0 equals 1 over 35, F1 equals 12 over 35, F2 equals 18 over 35, and F3 equals 4 over 35. You just plug x equals 0. I gave you an example of F1 and F0. So F0 and F1. And then you just find F2 and F3, continue use the same probability function. Okay. Then we just find expected value. Expected value equals, you add x times fx. Okay, basically it equals 0 times f0 plus 1 times f1 plus 2 times f2. Okay, plus 3 times f3. And then you just plug it in, and you find the final answer equals 1.7, which is not really hard. Okay. So in this one, I think it does give you the probability. Okay, you can read the point 4.4 by yourself. Let's look at another one. Let me say a continuous example. Continuous function, the fx is given. Fx equals x cubed 20,000. Okay, x bigger than 100. Now we want to find the expectation value. Expectation value is defined as negative infinity to positive infinity x fx dx. But here it says x is bigger than 100, so we would have to do stuff from 100 to infinity. and x multiplied by the fx. Okay, so dx. Now we plug it in, we have 100 to infinity, and x times x cubed, and then 20,000, and dx. Now we simplify that, equals 100 to infinity integral x squared 20,000 dx. Then this one is the antiderivative, so 20,000, you add 1 on the power, becomes x to negative 1 power. Then this is, you can change that into x to negative 2 power, this is x to negative 2. So we add 1 on the power is negative 1 and divide it by negative 1. Then plug in infinity and 100. So this gives you negative 20,000 and x. Then you plug negative infinity and 100 in. So the final answer, infinity plug in 0, minus is plus, 20,000 divided by 100. So the final answer is just 200. Okay. All right. So this is how you got the how you do it for the continuous variable. Next one is the theorem 4.1, and it says let x be a random variable with probability distribution function fx. The expected value of gx is, okay, so basically it says the expected value of random variable is a function. So you have u of the function g of x equals e over gx, and equals, you can multiply gx times fx. Basically what it says, now the variable is a function. Okay, so it's pretty much the same. Previously you have u over x equals of just fx times fx. Okay, so it's pretty much exactly the same thing, not really difficult. Then x is random variable, then discrete if fx is discrete and ugx is if it's continuous, it will just change the x into a gx. That's not really super difficult thing, just to change the x into a function of x. Okay, so let's look at 4.5 as an example. Let x be a random variable and fx is given. Find the expected value of gx. Gx is a function for x plus 3. Now we're looking for the expectation value of gx. So expectation value of gx equals, take the antiderivative from negative 1 to 2, and it's supposed to be gx times probability of fx dx. Okay, and then it's negative 1 to 2. Gx is given as 4x plus 3. Multiply the derivative, the fx is given x squared over 3 dx. Now we just do the integral, negative 1 to 2, 4x distributed is 4x cubed over 3, plus 3x cancelled is just x squared dx. Now take the antiderivative. First one, you will add 1 on the power, so it's x power 4, divided by the 3 times the new power, plus, then the new power is x cubed, add 1 on the power, divided by the new power is 3, and then plug 2 and negative 1 into the function. Okay, then you find the antiderivative, plug 2 into here, plug negative 1, so it's 4 times 2 to the power 4 over 12 plus 2 cubed over 3 minus 4 times negative 1 to the power 4, 12 plus negative 1 cubed over 3. Then they find the final answer is going to be 8. Okay, so that's how you do the this one. If we have if the function is two-dimensional function, if we have a two-dimensional function, then the ug of x, so basically it's two-dimensional, u over g of xy, so equals e g of xy. You have to add x direction and y direction at the same together. Xy, gxy is the function of xy, and fxy is the random variable function. This is the probability function. Okay, then multiply them together. It's very similar as u over g of just one dimensional. You just have e to power x and the g over x and fx is the probability. Okay, so two-dimensional, you just have two of you have add twice, and if it's continuous, you have to do a double integral for dx and dy and dy. Okay, and there is an example here, example 4.6. I do not think it's really hard to look at. Basically, you just have xy times fxy, all of them together. Okay, so you get fx, x is 0, 0 times f 0, 0. Okay, you can check 0, 0 times f 0, 0, 0, 1 times f 0, 1, 1, 0 times f 1, 0, 1, 1 times 1 f 1, 1, 2, 0 times f 2, 0. So you multiply everything, you add them together, you find the expectation value. For two-dimensional, you given find the ey of y over x. So it's given 0, x is from 0 to 2. Example 4.7. So here we have the fxy is given a function, probability function is given. fxy is 4x times 1 plus 3y squared. Now x and y boundary are given. 0 x less than 2, 0 less than y less than 1. And now it asks you to find the expectation value of y over x. Okay, y over x. So here, and we can tell that. Okay, we can tell that e y of x. Note that if g of xy equals x in the definition of 4.2, so we have e y of x equals, you take the integral from 0 to 1, take the integral from 0 to 2, which is the x, and then you have y over x, which is the variable, plug into here, multiplied by the function, the probability function x, 1 plus 3y squared, and 4, and dx and dy. Okay, and then that's how you have in the book that x cancel out 0 to 1, 0 to 2, and 0 to 2 is for dx. So x canceled out, you have y, 1 plus 3y squared over 4 dx dy. Okay, this is the antiderivative thing, so it's 0 to 1. First take a derivative with respect to x. So we just have, we don't have a variable x here, so we just have y, 1 plus 3y squared over 4, and you plug x, you multiply by x, okay, because the derivative, antiderivative with respect to x, so you multiply by x, and then plug 2 and 0 in, and x is 0, so x is the 2 now. So plug 2 as the x in is 1, plug 2 into here, so it's 2, y times, okay, y times 1 plus 3y squared, and 4, plug 0 in 0, so we have dy, okay, and then we cancel it, is 0 to 1, can reduce, that is 2, so it's y plus 3y to the power 3 over 2 dy. Now we take the antiderivative, it's going to be y squared over 4 plus 3y to the power 4 divided by the new power is 8, plug 0 and 1 into it, and then you have plug 1 is 1 over 4, plug 1 is 3 over 8, plug 0 in is just all 0, so final answer is going to be 5 over 8. Okay, this is the integral part. Alright, so it's not really a very difficult definition. You're going to have some problems to practice in your homework. Okay, and I will create the videos for 4.2 and 4.3 later. This should be okay, not really hard one. Okay, let me just upload this one right now.